After doing our exploratory factor analysis, we know that we can still go with our confirmatory factor analysis. So what we first need to do is to import our data. So I'll quickly click on select data file, file name, locate my data, which was this, select this, open, and I'm good to go. So the next thing I need to do is to know the number of variables or number of indicators under each latent construct. So when I click this, I can click here, and drag it so that I can, okay. So it means that when you look at here, we have 11 what items for attitude, whilst another 11 for practice. So what we need to do is to construct structure with 11 items for each. So I'll quickly click on this, draw a latent variable or add an indicator to a latent variable, click and hold, and draw this. I'll just click on in the middle or any part with, you see, it becomes red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I can do same again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the next thing I'm supposed to do is to load my items onto these structures. So I'll just click on list variables in dataset, click and hold this, drop here. Make sure it's reddish before you drop. So you do same for all items under each latent construct. So I'm going to do this. Same here. Do same for this. I can start from down so that whilst moving this thing to be easy for me. Just want to move this, but it's not minding me. It's not responding. So okay. So this way. So I can decide to arrange them the way I want. But since these are large number of items, I can do the rotation. So I'll click on rotate the indicators of a latent variable, and I can do it this way. So this will be easy, you see. So I can decide to arrange them by clicking on move object, preserve symmetries. I can move it this way, create a correlation because we are going to do exploratory factor analysis. You can decide to do for only one construct without doing any correlation, but you still get a good this. But since you have two, you can decide to do them concurrently. That's why I said Amos or SEM allows you to do so many things at the same time. So we can decide to check these two skills together while doing modification to our model, or that is the measurement model. So I'll click on correlation and draw. So since this is not down, I click on the touch up a variable, click here and this. I can decide to say that these are very close. I might not see the estimate. So I can deselect preserve symmetries, move objects, select it, do it this way. Do same for this. Come back to touch again, click on this, and I'm good to go. So the next I'm supposed to do is to label my constructs. So I'll double click on this, put let's say attitude, no spacing, attitude. You can ignore this box, just move it to the next, click on here again. Then you can say practice, and you are good to go. So we're supposed to label these ones too, which might be time consuming. So I can just quickly click on plugins, name unobserved variables. Then I can save my data. So for the first time, if you don't have your data or your analysis part saved, you have to do that. So since this is selected, I need to deselect. So I can just here deselect all, and I am good to go. So I need to check the factor loadings. So I'll just click on here. I don't need implied correlation, implied moments. I don't need this now. So I just need standardized estimates. So I'll click on calculate estimates and wait for this. So in order to see the output, you see this, view the output path, click here, you see. So when you see a loading, that's this ones above 1, it means that they are unstandardized. So to get standardized estimates, click here, standardized estimates, and you can check them. So once you check this, the next thing is to check is your model fit. So as compared to uh, Smart PLS, you are able to check your model fit measures. But one difference between these two is that Amos gives you all the measures except the construct validity and reliability, which you have to check it using the plugins we installed earlier. So you just click on the output here, look at model fit. Our model fit, the C mean divided by degrees of freedom is less than 0.4, which is adequate. We have TLI, CFI, all above, and IFI above 0.9, which is adequate. RMSC is 0.10, which is bad. So I think let's check the construct validity and reliability. So we can close this, save our data again, click on the plugin. We have validity and reliability, master validity, no ATMT. So you can set to choose this or that. So I always go with this. So master validity dot, click this and wait. Okay, this is not present. Let's try the second one and see. The process cannot is being used by another. So this means that we have SPSS opened. So we have to close it. So we close SPSS before we can get that. So we rerun again. Let's use this. If we still not get it, means that we have another file. Okay, it means that we have another data. So we can start to close it, save, come back to this, open Amos tutorials as a file, click on this again, check to see. Okay, when it goes off like this, you need to open it again, maximize it, check again to see whether you can get the estimates. Okay, so it's in, you can choose any browser of your choice. So I'll go with Opera Internet Browser. So I'll just click on this. So it always come as HTML file. So you see composite liability 0.96, which is about point. So composite liability should be above 0.7 or approximately 7. So this is met. AVE is used for convergent validity. So with convergent validity, it should be above 0.5. So you can see here we have 0.738, we have 0.724, which is also okay. So when we go down, no validity concerns here. There are no warnings for this ATMT analysis. And this ATMT analysis is for the discriminant validity. It's used when you have two different skills, but when you have the same skills, you are always going to see issues and you should consider. So we don't do ATMT when you have the same skill or sub skills, but we do when you have different skills and you want to see how distinct they are. So if you have issues, it means that your skills are similar and you should need to do something about it. So there are no warnings for this, and these are citations. So this is a plugin we used, the one we uploaded or we imported into our plugin folder in the app data section. So since we don't have any issue here, the only problem we have is the RMSC. So let's say for instance we have the loadings are all above 0.7, so we can say that we have to delete. However, you might try to see whether there are other problematic items. So you can click analysis, come to output, click on residual moments, modification indices. So you analyze again by calculating estimates. So you wait. Sometimes the app might close, you have to reopen it again. So let's go output, Let's go to estimates, matrices. So because we checked in the residual moments, we will see something called standard residual. Listen, so let's check to see those that are normal, maybe above 2 or 3. So we see we have okay 2, okay, we have 2.0, okay, we do not have 3. So we can say that let's do some modification. So let's check the modification indices which was checked. So let's look at the changes we can get. So with E2, so one thing you should know about modification indices is that it suggests that by covering this error term and this error term, your model may change or may improve. And we only covary items within one latent construct. So you cannot covary an item or error term under attitude with practice. But these items should be under the same construct. So what we need to do is to check this. What is E21 and E22? Are they within the same construct or scale? So E21 is here, E22 is here. We have E20, okay, E20 and E22. So this means that they are all within the same scale. So what we need to do is to co-vary them. So to E21 and 22, and so 22, 22, 22, 20 and 21. So we can co-vary 22. Okay, let's check it again. 22, 20 and 21. Okay, 22. So we can co-vary this way. The same. You can co-vary even one item with all and you conduct your analysis again. Let's check for the factor loadings and model fit. We still have the same factor loadings, but we need to check for the model fit. So we check the model fit here to see our RMSE whether there is an improvement. So let's look at model fit. Let's go RMSE. Okay, this is improving. It's 0.099, which should not be above 0.8. So we can check for modification indices again. E19, no, E19 and 21 can change by what? 21. So E19 and E21, are they within the same construct? E19 and E21, they are the same. We can co-vary. Let's do the analysis again. Let's look at the model fit. Once you do that, you check for the problematic indicator or measure. So you see it's now 0.09. Let's look again. Which one again? E17 and E20. But I think we have very large of which we could not see. E1 and E31 is 73. Wow, we did not see. So let's check. They will be under the same construct. E1 and 3, they are very close. We can cover E1 and 3. So you need to check down to see the others, or else you might think that you are covering the highest value, of which there are biggest ones. So you co-vary, analyze using calculate estimates, check output, model fit, RMSE. Wow, this is improving. Let's look at the model fit. Let's look for the highest again, which is 29, which I have seen, 28, 29, E12 and 17. Are they the same? Are they on the same construct? E12 and 17. E12, okay, they are the same. E12 and 17, they are the same. E7 and 12, no. E7 and 12, no. E7 is here. This 11, we cannot use it. Let's check this again. Modification indices for E17 and 20 is 28. Let's look for E12 and 17. No. 29. We saw another 29. Wow. E2 and E4, they are close. 32. E2 and E4. E2, E2 and E4. Let's go vary. Let's do again. Let's check the output. Let's check the model fit. It is somehow good. Let's check again. Which one again? E17 and 20 are very close. E17 and 20, E17 and 20, E17 and 20 is here. And we check again. Model fit, RMSC, problematic, okay, 0.088, which we can say is 0.8. We can decide to report it this way. But since for the purpose of this video, we co-varied so many error terms. Based on your research, you might get one error term correlation, or co-vary two or more error terms, and you get a good fit. But for the purpose of this video, we had to just go beyond that. Some literature says that you should not co-vary error terms unless there is a theoretical assumption. Some are also saying even if you are going to co-vary, it should not be more than 3. Some are also saying about 5. This is based on the type of research you are doing. So this is what you do. And once you are done, you can click on select all objects, copy the path down to the clipboard, open your Word document, and you can paste your model. And you are good to go. But you see that when you paste it, the error terms are not showing. It means that they are not in the right place. So you can delete this, press delete, come back. You can see fit or resize the pattern to fit on this page like this. Or you can bring it back. You can preserve symmetries, move it. This is not good. Okay, without symmetries, you can move it this way. Copy, paste, and you have a good diagram to present in your work. So this is how we perform confirmatory factor analysis using IBM SPSS Amos.